You want to know what happens if Earth got a second sun, working wings, or a moon that suddenly fell out of orbit? The honest answers are not thrilling adventures, but horrifying warnings of absolute cosmic destruction. Two suns would mean frozen oceans and eternal winter. Real, functioning biological wings would require a wingspan wider than a professional football field just to keep you off the ground. And one of these 10 scenarios ends with every human being on the planet sounding exactly like Donald Duck. We are walking through 10 extreme what-if questions, and we are letting actual, unforgiving physics answer them. What would happen to Earth if our solar system suddenly acquired a second sun? While science fiction paints a picture of beautiful double sunsets, the actual astrophysics guarantees a frozen apocalypse. To keep Earth from being immediately incinerated, the combined mass and energy output of those two stars would have to be significantly lower than our current single sun. Because of this necessary reduction in stellar energy, the average global temperature on Earth would plummet to roughly 200 Kelvin, which is almost 100 degrees below zero Fahrenheit. Within weeks, the albedo effect would take over, as expanding ice caps reflect away whatever meager light reaches us, freezing every ocean completely solid. Furthermore, the introduction of a second gravitational anchor would warp our orbit, stretching our calendar year well past the standard 365 days. But there is a much more terrifying possibility, known as the three-body problem. If Earth were caught in a chaotic figure-8 orbit between two widely separated stars, the conflicting gravitational tides would violently stretch the planet before inevitably slinging us out of the solar system to wander the dark universe as a frozen rogue planet. What would it actually take for a human being to fly using a pair of biological wings? Everyone assumes that human flight just requires strapping on the right aerodynamic shape, but the mathematics of lift and drag aggressively disagree. A standard 190-pound person operating under Earth's normal gravitational pull would require a staggering 43-meter wingspan to glide safely. That is nearly the entire width of a football field, requiring you to carry over 153 square meters of wing surface on your back. Strapping on wings was never going to work because human bone density and muscle mass are simply too heavy for our thin atmosphere. The only real scientific fix is changing the air itself, requiring an atmosphere 60 to 800 times denser than our current sky, with over 1,100 atmospheres of crushing pressure. In an environment that dense, you would not actually fly through the air. You would be neutrally buoyant, essentially swimming through the sky. To survive this crushing pressure without suffering deadly nitrogen narcosis, you would have to breathe a highly specialized synthetic mixture of neon and oxygen. Could humanity actually survive by drinking the water currently hidden on Mars? Colonizing the red planet sounds like a glorious frontier story, but the world we would actually land on is an irradiated, frozen, and completely barren wasteland. Liquid water survives in exactly one deeply hidden location, subglacial lakes trapped deep beneath the Martian South Pole. This water sits at a freezing -68 degrees Celsius and is kept in a liquid state purely by an extreme toxic concentration of perchlorate salts. Margins of survival that narrow would force us to rebuild human society from the ground up, entirely trading free market competition for mandatory militaristic cooperation just to process a single drop of drinking water. Astrobiologists would also be forced to enforce strict planetary protection protocols, establishing sterile zones to ensure that aggressive Earth microbes never contaminate those hypersaline refuges. If a Tyrannosaurus Rex magically materialized today, could it even survive our current atmosphere? A returning apex predator sounds terrifying, but the reality is that the beast would immediately drop to the ground, struggling to breathe. The Cretaceous period ran on dramatically higher levels of atmospheric oxygen, which acted as high-octane fuel for giant dinosaur metabolisms and provided the thick air density required for massive pterosaurs to achieve flight. Our current 21% oxygen atmosphere would leave a large dinosaur suffering from severe respiratory strain and would completely ground any flying prehistoric reptile. If we reversed the experiment and pushed our modern oxygen levels back to prehistoric extremes, human beings would suffer from acute oxygen toxicity, requiring us to live in heavily controlled, filtered biomes just to survive outside. The rest of the modern animal kingdom, however, would happily take the evolutionary opening. Ordinary modern ostriches could rapidly re-evolve into 90-foot predatory giants, and bats could grow wingspans large enough to completely black out the sun. What would happen to the Earth if gravity simply turned off for exactly 1 second? People imagine a brief moment of zero gravity as a fun, floating experience, but real physics turns this into a hyper-violent planetary disaster. Gravity is the fundamental curvature of space-time, so flattening that curve instantly snaps physical matter back into place with devastating force. The floor beneath your feet, no longer compressed by the weight of the building above it, would act like a massive spring, launching you violently into the air. In that exact same fraction of a second, the vestibular system inside your inner ear would completely fail, triggering instantaneous, paralyzing nausea and severe spatial dizziness. The effects would be far worse on a planetary scale, as the dissolved gases deep within the ocean would fizz into billions of massive bubbles all at once, creating devastating aquatic shockwaves. Deep underground, pressurized magma chambers would suddenly lose the billions of tons of rock holding their roofs down, immediately nudging every dormant volcano on Earth much closer to a catastrophic eruption. How long would humanity survive if every ocean on Earth instantly vanished? Losing our oceans sounds like a massive geographical inconvenience, but it would actually act as a rapid death sentence for the entire global water cycle. Our oceans regulate 70% of Earth's climate and rely on marine phytoplankton to produce up to 80% of the oxygen we breathe. Once the vast ocean basins are emptied, all remaining rivers and freshwater lakes would rapidly drain into the abyss and evaporate, causing global rainfall to essentially stop altogether. Without the cooling effect of the oceans, global temperatures would soar to an average of 153 degrees Fahrenheit. This immense heat would ignite continent-spanning forest fires, dumping millions of tons of carbon dioxide into the atmosphere and triggering an irreversible runaway greenhouse effect. Humanity's only theoretical shot at survival would involve a desperate retreat to Antarctica to build deep underground bunkers. What would our daily lives look like if Earth were exactly 10 times its current size? A significantly larger Earth sounds like a paradise with endless room to spread out, but the final result depends entirely on planetary density. If you multiply Earth's radius by 10 while keeping our current density exactly the same, the mass of the planet jumps by a factor of 1,000, pushing surface gravity to a crushing 10 times what we feel right now. Under 10 Gs of force, simply walking to the kitchen becomes exhausting. Rain falls from the sky at lethal velocities, and commercial airplanes would require extreme rocket-level speeds just to generate enough lift to get off the runway. If we magically kept the gravity normal instead, the planet would have to drastically lose density to balance out the physics, turning our rocky Earth into a massive gas dwarf closer to Saturn. In this gaseous world, we would live in pressurized, sealed dome cities, floating entirely on hot hydrogen balloons. Because of the thin atmosphere, we would be forced to breathe a synthetic helium-oxygen blend, which would permanently alter our vocal cords and make every human being sound exactly like Donald Duck. Is it physically possible to build a solid planetary ring around the Earth? Building a metallic ring around our equator sounds like the ultimate pinnacle of human engineering ambition, but a solid static ring would absolutely not survive.
Unpredictable gravitational anomalies and the constant pulling of lunar tides would act on a solid ring exactly like a hula hoop, violently sliding it off-center until it collided with the planet's surface. The only scientifically valid version that actually works is a dynamic orbital ring. This megastructure uses an inner rotor composed of magnetic particles moving at blistering supraorbital speeds between 8 and 10 kilometers per second. This incredibly fast inner movement generates the extreme centripetal force needed to magnetically levitate a completely stationary outer armored sheath. From this stationary outer ring, massive cables called Jacob's ladders could be dropped straight down to the Earth's surface, acting as space elevators and making traditional chemical rockets completely obsolete.
If the moon started falling toward Earth, what would the final 64 hours look like? A falling moon sounds like a slow-motion disaster you would watch coming in the sky for years. But the real mathematical timeline is a terrifying 64 hours from the start of orbital decay to total planetary chaos. As the moon approaches, its massive gravitational pull would amplify ocean tides into unstoppable 200-meter-tall tsunami waves, while triggering magnitude 9+ earthquakes across every single fault line on Earth simultaneously. However, the part almost nobody expects is that the moon would never actually hit us intact. Somewhere between roughly 9,496 and 18,261 kilometers away, the moon would cross Earth's Roche limit. At this precise, invisible boundary, Earth's massive tidal forces would completely overpower the moon's own internal gravity, violently tearing the entire lunar surface apart into a glittering, shattered ring of debris. That trillions of tons of debris would then rain down upon the atmosphere, releasing kinetic energy equal to 100 million Chicxulub asteroid impacts, instantly boiling away every ocean we have left. Does time actually stop when you travel at the speed of light? Time freezing entirely sounds like the most dramatic, reality-breaking scenario on this list, but it might actually be the quietest experience in the universe. If time suddenly froze for 5 seconds relative to some higher dimensional observer looking down at us, you would never even notice because the atomic clocks on your wall and the electrical neurons in your brain would freeze right along with it. However, astrophysics already gives us a very real version of frozen time, and it is happening right now all around you. According to special relativity, as an object's speed approaches the speed of light, time dilation gets drastically more extreme. For a massless photon traveling at exactly the speed of light, proper time mathematically equals absolute zero. From the actual perspective of the light particle itself, its explosive emission from a distant star and its sudden absorption into your eye happen at the exact same instantaneous moment, no matter how many billions of light years it crossed.
Light experiencing absolute zero time raises a massive, mind-bending follow-up question. If a photon never ages from its own perspective, what would physically happen to a human body that managed to accelerate close to that exact same speed? The next video, linked directly on your screen, walks through exactly what your internal organs and your own biological clock would do as you approach the speed of light.